Hello everyone, this is team number 41D from Malviya National Institute of Technology, Jaipur. The title of our project is Online Low-Cost Unbalanced Source Identifier. In the hardware setup of the three-phase load, we have used resistance, inductance as well as capacitive components in order to consider all kinds of loading conditions. Each phase consists of a resistance whose value may vary from 0 to 300 ohm in series with an inductance of 0.17 Henry and a capacitance in parallel to these whose value may vary from 0 up to 21.1 Farad. We have also used a current measuring IC powered by a 7805 circuit to measure current variation during balance and unbalancing condition. The IC transduces the current variation into voltage signal, which is being fed to the MSP 430 based experimenter board, which sends the signal of balancing or unbalancing to MATLAB via serial port, which plots the data, where balancing is being shown by value 0. Now at this point of time, the loads have been balanced and hence the current in each phase is equal to each other, that is 0.8 ampere. We'll start from phase 1. The current in phase 1 is equal to 0.8 ampere. We'll check the current in the emitter of phase 2. The current in phase 2 is also 0.8 amperes. The current in phase 3 is almost equal to 0.8 amperes again. The current at point of common connection is almost negligible, which can also be verified by the value of LCD screen. The LCD is showing the balancing notification as well as the value of voltage which is being fed to it by the current measuring IC. In order to create unbalanced condition, I will change the values of current in all three phases by varying the values of resistance and capacitance in each phase. We'll start from phase 3. The resistance in phase 3 has been decreased and the capacitance has been increased to 5 Farad, resulting in increase of the current in 1.22 amperes. Similarly, the resistance in phase 2 has been decreased, due to which the current has been increased to 1.1 amperes. The capacitance has also been increased to 3 farads. In phase 1, the resistance has been increased, due to which the current has been decreased to the value of 0.74 amperes. The visual signal of the unbalancing has been shown by experimenter board in form of red LED glowing signal. The unbalancing signal can also be seen in the emitter of point of common connection, where there is a considerable amount of current. The unbalancing conditions have also been plotted in MATLAB through the data which is being sent to it by the experimenter board. Now here you can see that due to unbalancing, the value has been changed to a higher value, as well as the signal is being pulsating due to the unbalancing which is being shown there in the circuit. Now again, I will retain the values of all the currents in all the phases equal to 0.8 amperes in order to take down all the loads to a balanced condition. We'll again start from phase 3. The value of current in phase 3 is again equal to 0.8 amperes. The value of current in phase 2 has also been retained to 0.8 amperes. Similarly, the value of current in the phase 1 has also been decreased to 0.8 amperes. Now we can see that at the point of common connection, the emitter is showing a negligible current. That means that the whole load is balanced. The signal is also being shown by the experimenter board, where the value is being shown of the current carrying IC and the balancing notification has also been shown. The data through it has been passed to the MATLAB through the serial port, and now the value has again changed to 0 because the whole load has been balanced. Hence, we demonstrated that how, by exploiting a simple characteristic of a 3-phase 4-wire system, that the current at the point of common connection is almost negligible when the load is balanced. Thus, by the use of a current IC and experimenter board, we can measure that current and can decide whether the load is balanced or not.
Right now, we have implemented a hardware in which a single unbalanced source identifier is connected to single MATLAB server. But in real system, there would be thousands of unbalanced source identifiers which would be connected to MATLAB server. These many number of hardware circuitry may lead to inconsistency in case of simultaneous unbalancing in more than 2 circuitry. So we have proposed Java sub-servers like this in between microcontroller and MATLAB server to reduce inconsistency. This is our Java sub-server which would be connected to MATLAB server. Now it is connecting. Now we would call this function of MATLAB PowerCL to send information about balancing and unbalancing to the MATLAB. Firstly, we are sending the signal of unbalancing as 1, as you can see in this figure. Now after this we will send the signal of balancing as 0, as you can see this in this figure.